Hello friends, thanks for joining me in today's lecture. What are the expressions? It is a compute values within a configuration. When I say within a configuration, it means you are trying to create some resources, but resources is going to have some kind of a dynamic data probably. Like you are expecting some input variable, you are relying some function, and you expect that computation to have some kind of end result, and that end result will decide whether to create the object with those information or not. In the same set, we have certain information like version, function, splat expression, and dynamic expression. So this version parameter is used to tells to restrict the configuration or restrict the instruction to particular version. We will see it into the lab session in detail how you can have the versions in between, but as of now this kind of expression we have. The function name is basically the name of the function which is available into the configuration language, available into the Terraform configuration language. It expects the argument as like simple, any programming language. Splat expression is nothing. It is a kind of a short form of, having a loops. So for example, these loops is there, then you can convert into the short form of using a splat expression. There's one more expression which is called dynamic expression, which is very similar if you want to provision more than one resources and their generation is dependent upon some expression calculation or some logic calculation. You can use the dynamic block. So next segment is in Terraform terms is data source. This data source block is used to get information about any existing resources created either by your script or some Terraform script, some other Terraform script. So basically it is a kind of, if I relate into the API or other thing, it is a kind of a get call which gather the information about any existing resources already created by some other script, some other Terraform script. So in this set, there's a two type of data source. One is the local only, and second one is remote. So basically, when say local only, it is used to generate some kind of a template, policies, or any file related stuff is limited and dependent upon the source path which required during the execution. So it can be used within your Terraform coding or Terraform configuration to run. This could be useful while you are writing some kind of a Terraform configuration which needs to interact with some kind of a policies or need to have some kind of a template information. The second type is remote, which depends upon provider's exposed API. For example, if I want to get the information of bucket or any EC2 instances created, I can use this data block to get those information from the provider's API. So this data block basically, when we say in remote terms, is used with the help of plugins API, and they have exposed some. It is very similar to the resource, but if I in terms of CRUD, this is a read only. It doesn't do anything. It just get the information whether it is present or not. And resource block is something which can be used to create, update, or delete. The syntax generally is same as resource block. We have a keyword data, we have a name of exposed API from the provider and the identifier name. And we have some certain information. This will work as a filter to the API, and this could be different from provider to provider. And even this could be different from provider APIs to API. How we can access this data block? It is very similar to the other block, similar to variable, similar to the output section. We have to call data dot the name of method, the name of API. For example, in this case, data dot underscore AMI dot example. So as said, it is a read only. This could be informational purpose to pass these values, the get values to certain resource block. Meta arguments, basically these arguments are available with almost each block: resource, data block, resource block, and variable block and output block. But there are certain limitation. Few blocks are having limitation which will be available to the certain block type. In this segment, first type, the first argument is depends on. This depends on is a meta which tells Terraform to wait for something to happen when Terraform automatically cannot decide. For example, you have to provision EC2 and load balancer, but what you want first EC2 be provisioned and then your load balancer has to be created. Then you can use depends on argument into load balancer resource configuration block, and you can pass the EC2 instance reference there to tell Terraform to wait and to start this execution. They start this execution of load balancer only if EC2 has been provisioned. So depends on is basically to create a dependency between the resources. The next one is count. The count, as name suggests, if you want to have one or more resources to be provisioned, then the count one can be used. And the second thing we will see in the lab session, how we can use count to make your resource block conditional. For is, as the name suggests, it is the same as loop, but here if you want to generate some set of infrastructure with slightly different configuration, you can use the for each. If you are aware about AWS, that you know most of the services of AWS is region specific. So for example, you have provisioned some EC2 instances in one region and you want a high availability and disaster recovery to have that happen. You want to provision more resources into different region. So using resource block and using provider block, you can explicitly tell Terraform to run those set of script, to run those set of configuration in a specific region only. The provider block is used to limit the scope to the region. The last one is lifecycle, but it has three types. Create before destroy. When we say create before destroy, so usually what happens when Terraforms identifies some differences in the state or unavailability of a state, then it tries to delete it. So in that say, what we can say, we want resources to be created first, then our resources should be deleted. So it means the first resources will be created and then the existing resources will be deleted. For example, how it can be useful, let me tell you. For example, you have created one bucket and now you decided you will change the bucket name from A to B, and you have this flag. What will happen? The first B named bucket will be created, and then once the successful creation of named B bucket is done, then bucket A will be destroyed. Then bucket A will be destroyed. The second type is prevent destroy. So as you know, everything in the Terraform is based on state, infrastructure, the configuration. So any changes detected into the state, probably we'll talk about what is state, but anything Terraform detects, then it goes for destroy. For example, that example we have seen into the create before destroy. If you want your name to be changed, but you don't want your previous resources to be deleted, so you can add this lifecycle flag prevent destroy. In that case, what will happen? Terraform will skip the deletion process and only go with the creation process. So inside this CRUD operation, this D will be missing for that specific object. So D will be skipped. Ignore changes. For example, now you have decided instead of having EC2 or other for now, let's say you want to add more resources, or you want to provision more infrastructure, basically object into the AWS. Earlier you had buckets, two bucket, now you want to have EC2 and other Lambda, other services like that. So ignore changes will let Terraform to know whether I have to take any action when any change is detected, or we just need to pass on. What does it mean is, if you have, suppose you have a configuration which only provision the buckets, but now after a few days you decided you will add some more script to provision the EC2, to provision the Lambda, to provision the API gateway. And that case, if you if Terraform found anything changed respect to your bucket information, then what should happen? Ideally it will delete it, or it will do as per the information found into the detection. But having ignored changes, it will be skipped. No action will be taken on those resources created earlier. So that I talked about, meta argument. I talked about the terms like segment, what is provider, what is the resource block. The most important thing is state. Everything in Terraform is state. So what is state? It tells the current stage of infrastructure with respect to the configuration. Okay, so suppose you are writing your Terraform script for the first time. At that time it doesn't have any state, it doesn't maintain the state, so it will be kind of empty state for Terraform. But after having one execution, the Terraform generate one state file to compare all those upcoming changes with the previous one, and on basis of comparison it decide whether any action against the infrastructure has to be taken or no. So basically there are certain type of action is taken. For example, if it is an empty stage and it is running for the first time, so straightforward the create action will be taken against your configuration. But you are running for the second time and there's a slightly difference into the existing resources and there's no major changes, then maybe update in place action can be taken. For example, if I take example of bucket, for example, you have named a bucket name as A, and you have earlier in the initial you have tagged the name, you have kept the tag as a name environment. Now what happened, while you are adding new infrastructure or you are adding new resource block, you have changed the bucket A tag from name environment to name environment 1. So in that case, what action will be taken? Terraform will compare the state from previous to the next plan, and it will do the changes into the place. So nothing will be impacted, only because these are the minor information for them. There's a no huge changes. So what will happen? Terraform will do the operation in place. It will just replace the, it will delete the tag information and it will recreate. Why the update in place is happening? Because your script is not trying to remove the existing resources, but it is just adding and replacing some information to it. So that is why Terraform decide it's not violating or it's not deleting the resource itself. The configuration you have provided is not being asked to delete or replace the whole bucket information, then it is simply update in place. The third one could be update and delete. So in that case, there's some information where it will update or some information it will be delete. And the last one is delete. The delete itself, name suggests, if it found the changes in the configuration can lead to destruction of the infrastructure, then that resources will be marked into the delete phase. So in Terraform, not in Terraform, basically in any programming language, we have certain kind of standard. As like other programming language, in Terraform we have certain standard or certain naming convention to write your script. So there's a basically, if you see, there's a three type of extension we use. Star.tf or star.tf.json is used to write your configuration, is used to write information, basically that segment, that blocks we are talking about, the resource block, the data block, the variable block, or the output block. .tf vars is basically used for having information about variables. There's a multiple ways to do it, but if you're using .tf vars, it means you have provided the values respective to the your variable. The third one is .tf state. When the first time Terraform start executing, it creates the Terraform.tf state. So when we talked about state and the file communication, so there is a certain way to manage how the state can be managed in different way. Okay, because if you talk about industry level, there's a certain way to achieve this, and you want this state to be shared or managed globally, so you can basically have the comparison at one place. For example, if you are in some organization and you want to uh, give that facility, so anybody can write the script, anybody can provision that, so you must have this state to the some global access place. So in that regard, we have a two type of way of doing it. One is called local state and another one is called remote state. When we say local, it means it is scope to your set of execution. It will remain on your system until and unless you make it, or you push it globally, or you push it somewhere, or you keep it stored somewhere else. When we say remote, we tell Terraform to do this job on your behalf. So instead of having manual interaction to upload the state from local to some other shared resources, you can use remote setup block. That will be a kind of instruction for Terraform to do this, to have this terraform.tf state defined there. For example, let's say everybody knows how to use the Git and all that. When you say Git is remote, or maybe GitHub or any other shared, say hosted library, any other hosted repository, then we say remote, it is the remote place where your central code is located. But when you write something, you commit something, it gets stored on your local until and unless you push it and it gets stored into the state. The similar way we can have this, we can imagine the state of Terraform. When we say local, it is stored on your local. When we say remote, it is stored on some shared accessible places. That is all for this lecture. We'll see you in the next lecture with the lab session. Thank you very much.